Okay, we're going to define hydrostatic pressure. So here I have a container of fluid, we'll just say water to be generic, and I've marked out this column of the water. Now that column of water is not moving anywhere, it's not accelerating up or down, so I know that the net force on it is equal to 0. Okay, so let's try and find the forces. So as we've found, it's much easier to talk about pressures in water. So acting on this bottom part, we're going to have some pressure. Give it a better P there. And at the top, this container is open to air, and so I'm going to say that's P0, that's the air pressure. Now it could be that there's some piston on top applying a different force, a different pressure, but we'll just say there's some reference pressure up there. And then we also know that there's a force of gravity acting on it. So if I write out all these forces, I'm going to have the upward force of the pressure at the bottom of the column, so that's going to be that pressure times the area, minus the pressure of the air times the area, so that's the force from the top, minus mg, that's going to equal 0. Okay. Now the mass of that column is going to depend on the height of the column, okay, and its cross-sectional area. Okay, I'll put a little a down here, the same the area we've been using for the forces due to the pressures. So now I can write PA minus P0A minus rho, and then the volume would be A times H G equals 0. So remember, what we did here is mass equals rho V, which in this case is rho AH, because it's a cylinder of height H and cross-sectional area A. Now that's really nice because we can cross out all of our areas, so that arbitrary column of water didn't matter. The only thing that's important is the height of that column, and I can rearrange this now to say that the pressure at the bottom of that column is equal to the pressure at the top of the column plus rho GH. Okay, rho GH. And so this rho GH right here, that ended up being the pressure difference. We sometimes call it the pressure differential. It's the pressure difference between the top and bottom of that column. And so we should be able to find out what the pressure is at any level, any depth h, in a container of water by just measuring its depth and knowing the density, and then knowing the pressure at the top of the container.